If I am writing 0 in the decimal, in the binary it is equal to 0, even in the octal it is 0 in the hexadecimal. If you are getting a word decimal first to any other number system, by that any other number system base you have to divide the decimal number. When we are converting from decimal to binary, the remainder will be only deal with the zeros and ones. If it is containing 137.56 base 10, then I can call this kind of number as what? Decimal fraction. Hello everybody, a warm welcome to one and all. Welcome to the session 5 of Unit 1 in the BCA's first semester subject called Fundamentals of Computers. As we all know that in this session we will be learning regarding this number system. I am Rohini TS, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence, MYSURU. Before getting into our today's session, we'll just have a quick recap of our previous session. As we discussed in the last session of this unit, we had a discussion regarding introduction of this number system. So we got to know what you mean by introduction of this number system. We got to know what is the definition of number system and why it is necessary. And also I had a discussion regarding the types of number system. We have a positional and non-positional number system. In the positional number system, it is of 4 types. One is decimal number system, and we have a binary number system, octal number system, and we have a hexadecimal number system. This is what we have as a positional number system, and we have one more type, that is non-positional number system. In this non-positional number system, Roman number system comes under this category. This is what I had a discussion in the last session. So in our today's session, we're going to see how we are going to convert from one number system to another number system. That is what number system conversion. In our today's session, we are dealing with this conversion from decimal to binary. First, in order to get into this one, you have to understand what is decimal and what is its base, how it is going to be represented with a power of what. That and all you have to remember. We are converting a decimal number to binary. If it is decimal number, it will be from 0 to 9. I am converting the combination of 0 to 9 numbers into binary. Then it will going to deal only with 1 and 0. And we can also convert this decimal fraction to binary. For example, if I am writing 917, this is what decimal number, its base is 10. If I am writing 7.356 base 10, this is what decimal fraction. Why? Because here we have a both whole number as well as the fractional part. That is what we are converting from decimal fraction to binary. This is what I am converting in our today's class. Let me get into our today's session now. So here you can see that before the conversion you have to understand what are the numbers which comes under decimal, binary, octal or hexadecimal. So here you can see that when it comes to the decimal number system, its base is what? 10. For the binary, its base is 2. For octal number system, the base is 8. So for hexadecimal, the base is 16. So in this decimal, if it is base is 10, totally it will going to have 10 digits. So it will be from 0 to 9. And for base of 2, that is what binary number, it dealings with 1 and 0. For base 8, it will be from 0 to 7. For base 16, that is what hexadecimal, it will going to deal with 16 digit, that is from 0 to 15. Out of this, 0 to 9 is the decimal number and A to F is the 10 to 15. So A stands for 10 here and F stands for 15. So this is how we are going to have our numbers which is in particular type of number system. Decimal 10, 0 to 9, binary 2, 1 and 0, octal base is 8, 0 to 7, hexadecimal 16. That is what 0 to 9 and A to F. A stands for 10 and F stands for 15. So here you can see that in this table we have a conversion of decimal numbers to its equivalent other number system. So if I am writing 0 in the decimal, in the binary it is equal to 0, even in the octal it is 0 in the hexadecimal. Then what about 1? So up to 0 to 9, it will going to be same from decimal to octal and decimal to hexadecimal. Binary only you have to concentrate. So for that, in order to understand that, we have a format called 8421. We have a format called 8421. For example, here I have a number called 3. So by adding which and which number of this 8421, I will be able to get 3. I need to take 2 and 1. So in the place of 2 and 1, I am going to write 1 and 1. And remaining place will be filled by zeros. So then what is the binary equivalent of decimal? 3, that is what? 0011. That is what you can see here. So in the prior number you can have this 0011. Let me go to the 9. So here you can see that by adding which and which number I am able to get 9 out of this 8421. I have to go with addition of 8 and 1. So in the place of 8 and 1, I am going to write 1 and 1. For the place of 4 and 2, I am going to write 0 and 0. This is how we are going to convert the decimal to binary. So then what about the decimal equivalent of this octal in the 9? Then it will be equal to 11. So here you can see that up to 0 to 7 it will be same for the octal number, but after the 7 it will starts with 10. So this table you need to remember. What is the conversion from decimal to binary, binary to octal, octal to hexadecimal? How will be the standard number system table is all about. So for 15 in the sense what? F, that is in the hexadecimal that you can see here. Then how I am going to write 15? If I add 8, 4, 2, 1, 8 plus 4, 12, 12 plus 2, 14, 14 plus 1, 15. So, for all the letter or all the numbers, I am going to give 1, 1, 1, 1. So, if I wanted to have 13, by adding which and which number I am able to get 13 here? 8 plus 4, 12. 12 plus 1, 13. So, in the place of 8, 4 and 1, I will write 1, and for place of 2, I will write 0. Okay. So, here you no need to worry or no need to by heart all these values. This is just a standard value. You have to be able to understand how we are going to convert that given number to its base. Okay. By each conversion, you will be able to understand all these things. As of now, you just need to understand regarding this table. This is what number system table. Let me get into the conversion from decimal number system to binary. So simply we can't do it. Simply I can't say what 10 will be converted into 110, something like that. So we have to follow certain stages or steps here. We'll see the step 1. Divide the given decimal number by 2. And I will give you one tip here. When we are converting decimal to any other number system, what I am getting first? Decimal. If it is decimal, then you have to divide the given number by its equivalent number system. For example, if I wanted to convert the decimal number to binary, what is the base of binary? That is 2. So, whatever could be the decimal number, you would start dividing it by 2. So, if it is decimal to octal, then the base will be 8. So, divide the given decimal number by 8. So, decimal to hexadecimal, divide the given decimal number by 16. So, if you are getting a word decimal first to any other number system, by that any other number system base, you have to divide the decimal number. What if it is binary to decimal? Here the second word is decimal. So, for that reason, you have to multiply. If it is decimal to binary, divide it by 2. If it is binary to decimal, multiply it by 2. Okay, that is the simple thing you all need to remember. So, here decimal to binary. Divide the given decimal number by 2. Why? Because first you have a decimal number that is converted into binary number. So, you have to divide it by 2. Then, take the remainder and record it on the right side. So, we have to divide the quotient, and whatever the remainder that we are getting, that needs to be kept to the right side. In the step 3, we have to repeat the step 1 and step 2 until the decimal number cannot be divided further or the quotient becomes 0. We have to do the division of the given decimal number until that quotient reaches to 0, which we cannot further divided by the 2 as a binary number. At that point, you have to stop its conversion or stop its division. In the step 4, the first remainder will be the LSB. That is what? Least significant bit, which is having less significance. And the last remainder is the MSB, that is most significant bit. While writing an answer, the equivalent binary number is then written from the left to right, that is from MSB to LSB. First, we have to give more weightage for the most significant bit, then it will be given to the least significant bit. I will solve the problems, then you will be able to understand how we are going to do it. Okay, fine. Here I have a question. Convert the decimal number 87 base 10 to binary. So here what I am supposed to do, I have a number called 87 which is its base is 10. Now we have to convert this into binary. Fine. So how can I get to know this is a decimal number? Because its base is 10 and I need to convert this into binary and its base should be 2. Okay. Then what is the first step? Divide the given number by 2. So let me start with a division here. You need to write like this. Let me go with this one. 87. I need to divide it by 2. Okay. So 2 4s are 8. Then 2 3s are 6. Then what will be the remainder? 1. I need to write that remainder to the right side. Then again I need to divide this by 2. 2 2s are 4. Then 3 can't be divided by 2. I will go with 2 1s are 2. The remainder will be 1. Why? Because 2 1s are 2 in the sense what? 3 minus 2 will be 1. That's what we are writing here. When we are converting from decimal to binary, the remainder will be only deal with the zeros and ones. You won't get any other number than zeros and ones here. Then next 2 10s are 20. Remainder is 1. Then 2 5s are 10. The remainder is 0. Fine. Then 2 2s are 4. The remainder is 1. And then 2 1s are 2, the remainder is 0. We cannot divide 1 by 2. So here 2 zeros are 0, the remainder this one will be 1. So here the quotient is 0 now. I cannot divide the 0 by 2. So at this point we have to stop. When it can't be further dividable, then at that point you have to stop. This is considered as what? LSB or least significant bit. The last remainder is considered as a MSB. And you have to write the answer from MSB to LSB. What is the first remainder I got? 1, 0, 1, 0, 1, 1 and then 1. What is the base? 2. Okay, this is what the binary equivalent of this 87. Here you can see in the steps. That is what I had done here also. This is how we are going to root. Then when we are not able to divide this 1 by 2, here also you can stop it. Okay, or else if you want to go with another step, so just make it as what? 2 zeros are 0, the remainder will be 1. So it become 1 0 1 0 1 1 that we are going to write and its base become 2. Okay, this is how we have to convert from decimal to binary. Next, we'll have one more question here. Let me consider the number 137 which is of base 10 should be converted into binary. Okay, let me divide it. So here I cannot divide 1. So I will take 2 numbers here. It will become 13. 2 6 are 12 and 1 is remainder. Now it's become 17. So now 2 8s are 16. 17 minus 16 is what? The remainder is 1. Next 2 3s are 6. 2 4s are 8. Remainder is 0. Then 2 1s are 1. Here it will become 1 as a remainder. It will become 14 now. 2 7s are 14. Then remainder is 0. Again 2 8s are 16. Remainder is 1. 2 4s are 8. The remainder is 0. If it is divisible by 2 completely, then the remainder will be 0. Otherwise, you are going to get the remainder as 1 here. Then 2 2s are 4. Remainder is 0. Then 2 1s are 2. Remainder is 0. So at this point only I can stop. Why? Because I cannot divide 1 by 2. So here what I am supposed to do? 2 zeros are 0, the remainder will going to be this number. So this will be the LSB or least significant bit. This is the last remainder is considered as MSB. So from MSB to LSB we have to write the solution, so that hence 137 base 10 is equal to, what is the last remainder? 1 0 0 0 1 0 0 1 0 0 1 1 0 0 1. What is the base? 2. Okay, this is how we are going to convert any given decimal number to binary. I hope you all understood regarding this 137 converted into binary number. Here you can see the resultant. It only dealing with what? Zeros and ones. This is how we have to convert. Take one more number, 253 of base 10, and let me know the equivalent of this binary in the comment section. Let me move to the next topic, that is what? Conversion of decimal fraction to binary. decimal fraction to binary. We got to know decimal to binary. Now here I have a fraction number. If I am writing 137, that is what? Whole number. If it is containing 137.56 base 10, then I can call this kind of number as what? Decimal fraction. I need to convert this into binary number system. Then what are the steps we have to follow? We'll see. Multiply the given decimal fraction number by 2. Remember, fraction number by 2. Here we are going to have both whole number and then fraction part. So that whole number will going to be divided by 2 as we done for decimal to binary. But whatever the fractional part we have, which is right side to this decimal part, that is what we have to multiply it with a number by 2. Then note the carry and the product. We have to multiply it and we have to find out what is the product. For example, if it is 0.56, that is what? After the decimal, what we have is 0.56. So here 0.56, that means what? 0.56. I need to neglect this whole number. Then only we have 0.56. 0.56 is also means that 0.56. I need to multiply it with 2. Whatever we are getting out of it will be considered as what? Product, and we have to find out the carry. Then we have to do the same step again and again until the decimal number cannot be divided further. So when we are not able to divide this decimal fraction number further, or if the quotient becomes 0. So if the quotient value becomes 0, then at that time we have to stop doing this multiplication. Then the first carry will be the MSB. So if you consider the decimal to fraction, last carry will be the MSB in the decimal to binary. So if you consider the decimal fraction here, this is what? The first carry will be MSB, which is going to have more weightage, more significant bit. And the last carry is what considered as LSB. So here we have to write the given number from MSB to LSB. So for the decimal to binary, the output will be like this. For decimal fraction to binary, then we have to write like this. Why? Because in the decimal to binary, MSB will be here, LSB will be here. For this decimal fraction to binary, MSB will be here, LSB at the last. So this is what the difference you need to remember. We'll see the question here. I have an example 0.3125, which is of base 10, needs to be converted into binary. So now you need to understand, do we have any whole numbers here? Yes. What is that? 0. Fine. 0.3125. So here the decimal fraction is what? 0.3125 of base 10. So this 0 is what? Whole number. So no need to divide that by 2. So though I divide it by 2, then the remainder will be remain 0 itself. That's why no need to divide here. The remaining fractional part is what? 0.3125. What is the first step? I need to multiply the given decimal fraction by 2. So in order to do that, we have to follow one format here. First take the first column as multiply by 2. Then we have to maintain the carry as well as product. Keep the product at the last and carry at the mid, multiply it by 2. Let me consider the question 0.3125. Write it down, 0.3125, which should be multiplied by 2. So if it is multiplied by 2, 0.3125 into 2, then it will going to give the product as 0.625. So in this, how can I get to know which is carry or which is the remainder here? The number which we got before the decimal part, then we are calling this as a carry. So this 0 will be copied as a carry here. Then what I am left out with? 0.625. 0.625 is always same as that 0.625. Then again I will multiply this with 2. 0.625 into 2. If I am multiplying 0.625 into 2, then I will be able to get 1.25. So what is the remainder now? This one. This one is considered as a carry now, and 0.25 is the remaining quotient value here. So for this 0.25, again I can write it as what? 0.25, which needs to be multiplied by 2. If we are multiplying it, then we are going to get 0.50 as a solution. Again this 0 will be considered as a carry, and 0.50. Again this 0.50 will going to be multiplied by 2. So if I am multiplying 0.50 by 2, then the resultant will be 1.00. So here you can see that 1 will be considered as a carry and this 00. This is what quotient value. Decimal number become 0, 0. If I am multiplying it again with 2, then I am ended up with 0. At this point, we have to stop doing the multiplication. So here what and all we got as a carry which is before the decimal point, that we have to mention here. From here to here, we have to write the solution. That is what 0, 1. 0, 1 is the converted binary value for this 0.3125. So now what you mean by it then? 0.3125 which is base 10 which is equal to, what is the value? 0, 1, 0, 1. 0, 1, 0, 1 of base 2. This is how we are going to convert any given decimal fraction to binary. So now we got to know that how we are going to convert the decimal fraction to binary. Fine. So this is how, when we don't have a whole number here, only if we have a fractional part, then this is the procedure. That is also you can see in this manner. So what is the number? 0.3125, that will going to be multiplied by 2. At the time we are going to get 0.6250. This 0 which is left side to this decimal part will be considered as a carry. Then we are left out with 0.6250, that should be multiplied by 2. The same procedure which I shown in the previous slide, in this manner we are going to do it. So this is considered as MSB or most significant bits. This is the LSB or least significant bit. So for the value 0 in the question we have 0.3125. For this the equivalent binary number is 0. After that, put this decimal point. What is the equivalent of this 0.3125? That is what? 0, 1, 0, 1 which is of base 2. That we are going to write. This represents the binary point. Okay. Now we got to know how we are going to do this when we have only decimal fraction part. What if we have both whole number and decimal fraction? For that we have an example here. 152.671875 which is of a base 10 should be converted into binary. Okay. So here I need to separate it, which is the fractional part and which is the whole number. 152 is the whole number here. That should be converted into binary as we are going to do the conversion from decimal to binary. Whatever the remaining fractional part we have, that should be multiplied by 2. Okay. This is what the fractional part. This is integral part or whole number. So 152. We'll start divide this 152 by 2. Let me consider. So here I can't divide 1. I will take 2 here. 2 numbers 15. It will become 15. 2 7s are 14 and 12. 2 6s are 12. The remainder is 0. So 2 3s are 6. 1 is remainder. 2 8s are 16. Remainder is 0. Then 2 1s are 2. It will become 18. 2 9s are 18. It will become 0. So here we have a 19. Then 2 9s are 18. So 19 minus 18 will be, the remainder will be 1. Then this 2 4s are 8. The remainder will be 1. Then 2 2s are 4. Remainder is 0. Then 2 1s are 2. The remainder will be 0. And 2 0s are 0. The remainder will be 1. This is what most significant bit. This is LSB, last is least significant bit. This is most significant bit. For this, how we are supposed to write? 1 0 0 1 1 0 0. So in this manner we have to write. This is what I got an answer for this integral part 152. So let it be as it is. Let me go to the fractional part here. That is what we have 0.671875. So that number will going to be multiplied by 2. Okay. So when we are having it, then it will be the product, and this is considered as what? Carry. Okay. So this is what fractional part and this is integral part which we are getting as a carry here. So when we are multiplying it, we are going to get 1.343750. So I will take this one as an integral part, that will be considered as a first carry, that's nothing but what? MSB or most significant bit. Then 0.343750 will be multiplied by 2. Then we are going to get the resultant as 0.687500. This 0 will become the carry now. Then again 0.6875 multiplied by 2, we are going to get 1.37500. This one will be considered as a carry here. After that, 0.37500 will be multiplied by 2, 0.75000. The 0 will be considered as a carry now. 0.75000 will be multiplied by 2 again. Then we are going to get 1.500. After that, 1 is the carry here. Now it will become 0.50000 will be multiplied by 2. You are going to get 1.00000. Then this one become the carry here. So in this, we are left out with only 0.0000. That means we have 5 zeros here. Though I multiply it by 2, again I will ended up with 0 only. That's why at this point we have to stop. Then until this will be the result. Then this is MSB. This last one is LSB or least significant bit. How we are going to write it? 101011, which is of base 2. So now in the question we have 152 point, or this is what decimal point 671875. That should be converted into binary. So I need to write the resultant of this 152 first, then put a decimal point. Then it will be converted into that fractional part result, whatever we got will be written after that integral part. So for 152, what I got as a resultant 1001100. That I have to write first here 1001100 and put this binary point here. That is after the integral part, we have to write the value. For this fractional part, we got the resultant as 101011. That what I have to write here, which is of base 2. This is how we are going to convert any given decimal fraction to binary. The value will be only the combination from 0 to 9 in the decimal. Then it will be converted into zeros and ones. Okay, I hope you all understood regarding this conversion from decimal to binary and decimal fraction to binary. Let me meet in the next session with a binary to decimal. So here you can see that binary to decimal. Decimal is at the second word. Then we have to multiply it. Let me show you in the next session. And decimal to octal, again octal to decimal. That is what I will be discussing in my coming session. Let me meet you there. Until that, keep learning, keep on growing. Thank you.